In example 2, we need to determine the end behavior of the graph. So let's do the left end behavior. Notice we use the word end here, and behavior means what is the y value doing. To state the left end behavior, we want to state the values of x that are all the way on the left-hand side, and that would be negative infinity. This little arrow means approaching. So as x approaches or is approaching negative infinity, we're wondering what does the y do. This is your setup for the left end behavior, and then this piece will be different. This piece will be the same for all the graphs. This piece will be different based on whatever graph you're looking at. You'll notice that as we're on the graph, as we continue to the left or to negative infinity, the end of this graph goes up and up and up to positive infinity. Let me move this up a little bit for you here. The right end behavior would be as x gets very large or approaches infinity, we're wondering what does y do. So as the graph goes to the right, all the way down to the right hand side, what does the end of the graph do? And we're looking for the y value here. So the end of the graph goes to positive infinity. For the next example, we're going to do the same thing. We're going to do the left end behavior, and you can imagine that these would be, put some arrowheads on there if you don't have that on your graph right now. As x approaches negative infinity, what does y do? And we can see here that if we have this arrowhead, that as we go to the left, remember we don't care what's happening in the middle. This is the end. So as we continue, the graph will continue going down this direction to negative infinity. The right end behavior would be as x approaches infinity, y approaches some value. So this will be the same. You'll notice that it's the same for each one, but this, whatever that y value is, can be different for an individual graph. You can approach infinity or negative infinity or even a value. As we look at this graph though to the right, this graph looks like it continues upward, and it will continue with outbound. It will keep climbing. A couple more examples here in example 2. So let's do the left end behavior. You don't have to write the words left and right if you know that negative infinity is to the left. That's stating the left side anyways, but I just wanted to make sure you knew that for the past two. We're wondering what does the y value do. So as we continue to the left, the y value is going down and down and down. As x approaches infinity now, we're wondering what does y do. So as we go to the right, positive infinity would be down here. We're going up and up and up. For this graph, as x approaches negative infinity, this graph looks like it goes to positive infinity. This y value will keep increasing. Doesn't look like it settles out at a certain value. If this was a straight line horizontally, then we would say that it would settle out at that value. If there was a funny thing called an asymptote there, then that would be the case, but there's not. And to the right, this graph would continue down and down and down. So this piece stays the same for all of them, but then the value that y approaches will be the value here.